Guys, in this video we are going to discuss this series, this infinite series thing. I think I have given this problem to you in prac class 8A, I think, right? So here you can see that here you have n squared to the power n squared. To get rid of one of n's, you can use a root test, right? So we want to check whether this series is convergent or divergent, right? So therefore you can use root test. We know that this is a positive term. This is a positive term, right? So let's use root test. So this is your a sub n. Let's take this nth root of that, then you can get rid of one of n's, right? This is your a sub n, right? This one is your a sub n. Then n divided by n plus 1 to the n, right? Then we want to find the limit of this one. Either you can do this one here. So this one is with 1 over 1 plus 1 over n to the power n, right? So we know that. So the denominator goes to e to the 1 as n tends to infinity, right? That means, so this goes to 1 over e to the this thing. This one is 1 as n tends to infinity. Alright, so the value of e is something like this, 2.718, something like that. So which is greater than 1. So the limit is less than 1. Therefore, from root test, right? This series is convergent because from root test the limit is less than 1, right? Therefore this series is convergent. Right? So what can you say about this one here? So from root test you can simplify this one. So from root test, so a sub n, nth root of a sub n is something like this, 1 plus 2 over n to the power n, right? So as n tends to infinity, so this term goes to 1 over e to the power 2, because here you have 2, right? So we know the value of e is approximately equal to 2.7183 or something, right? So therefore 1 over a number which is bigger than 1, then this one is less than 1. So this one is less than 1. Therefore, from root test, this series is convergent. Is convergent, right? Let's look at this series here, right? So here we get the same factor here, same thing here, but in addition to that, we have 4 to the power n, right? So if you use root test, nth root test, when you simplify this, you get n over n plus 2 to the power n, because so here you have n squared. When you take root 10, nth root, we can get rid of one of n's, and here you have 4, right? So this one is a width 1 plus 2 over n to the power n times 4. So as n tends to infinity, this term goes to 4 over e to the e squared. So we know the value of e is 2.78 something. So here we are considering squared, right? So which is let me consider square of that, which is something like 7.389. So this number is bigger than 4. Therefore, the limit is less than 1. From root test, this one also, this series is also convergent, right? So if you don't use this one, you can use this if you want to find the limit of this. So let's do that one also. So I want to find the limit of this, where say n over n plus 2 to the power n, right? So suppose this one is suppose let's take a function y. Y is equal to x over x plus 2 to the power x. Want to find the limit of y as x tends to infinity. These are continuous variables, right? So let's take the ln both sides. So this becomes, right hand side becomes x ln of x over x plus 2, right? Right. So to find the limit here, ln of 1 over 2 over x plus 1 divided by 1 over x, right? So we know that as x tends to infinity, this term becomes very small, or this limit of this term is equal to 0. Then ln of ln of 1 is 0. Now what about this term? As x tends to infinity, this term goes to 0. Both denominator and numerator goes to 0. Therefore, we can apply L'Hopital's rule. I think you have learned in your first year. So, if the both numerator and denominator functions are going to 0 as x tends to infinity, you have to use L'Hopital's rule, right? So, from L'Hopital's rule, right? So derivative of the denominator function, where we don't have space. So here, let's from L'Hopital's rule, we differentiate the denominator function, which is -1 over x squared, and the derivative of the numerator function is 2 plus x times the derivative of this one here, x plus 2 squared, x plus 2, the derivative of x is 1 minus x. Do this one, right? So you will get, we can cross this off, and here, and one of terms we can cross. This cancels with this one of these terms, and finally you get negative. Finally you get something like -2, -2. Here we get 2 here, and here you have x squared, or something like this. Right. As x tends to infinity, what happened to this term? This term goes to 1. Then the limit of this entire term goes to -2 as x tends to infinity, right? X tends to infinity. So the limit of, so therefore yn ln y goes to -2 as x tends to infinity. That means y goes to e to the -2 y tends y goes to e to the -2 as x tends to infinity. That means this one also, this one is also going to e to the -2 as n tends to infinity. Both are the same, right? So here, so when you take this term to the top, this becomes negative, this becomes negative then, right? So if you don't like to use this one, you can do this. Using L'Hopital's rule, you can find the limit of this function, right? I hope you understood how to check the convergence of the series. We have discussed the series, the convergence of this series as well as this and this one. Right, see by